Hello, welcome to Unit 7, Lesson 16, the quadratic formula. Your learning objectives for today is you will be able to use the quadratic formula to solve quadratic equations, and you will know some methods for solving quadratic equations can be more convenient than others. So leading up to this, we have talked about several different ways to solve quadratic equations. We've talked about using factoring and then the zero product property. We've talked about just plain solving by taking the square root of both sides. We've also talked about completing the squares. Today we're going to be giving you a formula that you can use for any quadratic equation. Now, keep in mind, just like all those other methods, there are some benefits to using the quadratic formula, and there are some downsides to using the quadratic formula. So we will be exploring that today. Let's go ahead and take a look at the first activity. It says each expression represents two numbers. Evaluate the expressions and find the two numbers. So go ahead and pause the video. I want you to complete this without a calculator. Solve each expression and tell me what they equal. All right, let's go ahead and solve. So for number 1, that one's pretty easy. What you're going to do is first take the square root of 49, which in this case is 7. So you know that you're going to have 1 plus 7 or 1 minus 7. And then we're going to separate it into two problems. So we have 1 plus 7, which is going to equal to 8. And then 1 minus 7, which is going to be equal to negative 6. So your two solutions are 8 and negative 6. Okay, let's look at number 2. So number 2, we have 8 plus or minus 2 divided by 5. So we're going to separate this right off the bat. We're going to have 8 plus 2 divided by 5. 8 plus 2 is 10. 10 divided by 5 is 2. And then we're going to do 8 minus 2 divided by 5. 8 minus 2 is 6. And 6 over 5 is just 6/5. So your two solutions are 2 and 6/5. Okay, let's look at number 3. So for number 3, we have plus or minus the square root of negative 5 squared minus 4 times 1. So what I'm going to do first is I'm going to go through my order of operations. So order of operations say I do exponents first. Negative 5 squared is 25. Okay, and then I'm going to go ahead and do my multiplication as well. 4 times 4 is 16. 16 times 1 is 16. Next, I'm going to take 25 and subtract 16 from it. When I do that, I get 9. And then finally, I take the square root of 9. So my answers are going to be positive 3 and negative 3. Okay, let's take a look at number 4. So I have negative 18 plus or minus square root of 36 all over 2 times 3. So I'm going to do a couple things at a time. First, I'm going to take the square root of 36. So I have negative 18 plus or minus 6. 2 times 3 is 6. So now I have negative 18 plus or minus 6 all over 6. Now I'm going to separate it. So I have negative 18 plus 6 over 6. Negative 18 plus 6 is negative 12. Negative 12 divided by 6 is negative 2. And then I'm going to do negative 18 minus 6 over 6. Negative 18 minus 6 is negative 24. Negative 24 divided by 6 is negative 4. So the two solutions are negative 2 and negative 4. All right, let's move on to the next activity. All right, so go ahead and for this activity, you're going to choose one equation to solve either by rewriting it in factored form and using the zero product property or by completing the square, whatever choice you prefer, but just make sure you choose one of those. So go ahead, pause the video, choose one equation to work on. All right, so let's go ahead and start with the first one. So this first one's kind of tricky because we do have a decimal involved. So in my opinion, I don't think factoring is going to be the easiest method. Instead, I'm going to focus on completing the square. When I do that, I need to start by thinking if this one is, if we have x times x here, I know that this term is going to be made up of double x times some unknown. That unknown has to make it equal to -2, so I know my unknown is going to be -1. When I square -1, that is equal to +1. So the first thing I need to do is change my -1.25 into a +1. And I can do that by adding 2.25. And I'm going to do that to both sides. Oops. So now I have x squared minus 2x plus 1 is equal to 2.25. Next, I'm going to rewrite this as x minus 1 squared is equal to 2.25. To solve, I take the square root of both sides. So I have x minus 1 is going to be equal to 1.5, positive 1.5. And I also have x minus 1 is equal to negative 1.5. Square root of 2.25 is positive or negative 1.5. To solve, I'm going to add 1 to both sides of each equation. And I get x equals 2.5 and x equals 0.5. So my two solutions for this one are 2.5 and 0.5. All right, so let's go ahead and take a look at the second equation. All right, so the second equation reads 5x squared plus 9x minus 44 equals 0. So for this one, I think I'm going to do is I'm going to use factoring, but I'm going to do the factoring by creating a perfect square. So if I have 5x squared plus 9x minus 44 equals 0. First, I'm going to multiply everything by 5. So I have 25x squared plus 45x minus 220 equals 0. Now I'm going to pull the 5x out. So now I have the 5x squared plus 9 times 5x minus 220 equals 0. Next, I'm going to set n equal to 5x and rewrite this as n squared plus 9n minus 220 equals 0. So now I'm going to look for factors of 220 that add up to 9. I know that one's going to be positive and one's going to be negative. And the two that come to mind are positive 20 and negative 11. So I have n plus 20 times n minus 11 equals 0. Okay, now I'm going to take that 5x and put it back in place of n. So I have 5x plus 20 times 5x minus 11 equals 0. Next, I can set each equal to 0 and solve for x. So I'm going to subtract 20 from both sides. I get 5x equals negative 20, and then divide by 5, and I get x equals negative 4. For the other one, I'm going to add 11 to both sides. I get 5x equals 11, divide by 5, and I get x equals 11/5, or you could even say 2.2, whichever you prefer. So my two solutions are negative 4 and 11/5. All right, let's go ahead and take a look at question 3. So for question 3, my equation is x squared plus 1.25x is equal to 0.375. So what I'm actually going to do for this problem is I'm going to take it, and instead of using decimals, I'm going to use fractions. Fractions are a little bit easier to work with. And so let's go ahead and rewrite this, converting it to fractions. So I have x squared plus 5/4 x is equal to 3/8. Okay, so to figure out what I'm going to add to make my constant, I know since x squared is just x times x, I know I'm going to have to double x times some unknown. And in this case, that unknown is going to have to be 5/8, right? 2 times 5/8 gives me the 5/4. Next, what I'm going to do is I need to square 5/8. And I get 25 over 64. So this is what I need to add to both sides of my equation. So 25 plus 25 over 64 plus 25 over 64. When I do that, I get x squared plus 5/4 x plus 25 over 64. And then I'm going to quickly do some side work. So 3/8, as I need a common denominator. So that's going to become 24 64ths plus 25 64ths is going to give me 49 64ths. Ooh, I like that number. That's a nice perfect square number. So now I can write my perfect square. So I have x plus 5/8 squared is equal to 49 64ths. To solve, I'm going to take the square root of both sides. And when I do that, I get x plus 5/8 is equal to 7/8. And x plus 5/8 is equal to negative 7/8. To solve, I'm going to subtract 5/8 from both sides. So I get x equals 2/8 or 1/4. Okay, repeat that process. And I get x equals negative 12/8 or negative 3/2. So my two solutions are 1/4 and negative 3/2. All right, so let's go ahead and take a look at the last problem. So this one says 4x squared minus 28x plus 29. So let's write 4x squared minus 28x plus 29 is equal to 0. So right off the bat, I notice I have a perfect square for my first term, and that is when I do 2x times 2x. So I'm just going to finish solving this by completing the square. I need to multiply. I'm going to double the product of 2x and some number, and when I multiply that, I have to end up getting negative 28x. So that means that some number is going to have to be negative 7. And negative 7 squared is 49. So I need my 29 to become a 49. So let's rewrite this. 4x squared minus 28x plus 29 equals 0. To make it 49, I'm going to add 20 to both sides. And when I do that, I get 4x squared minus 28x plus 49 is equal to 20. I have my perfect square of 2x minus 7 is equal to 20. Now to solve, I need to take the square root of both sides. And one thing though that you may notice is that 20 is not a perfect square number. So that means we are going to have an irrational answer. So when it's irrational, we don't want to necessarily round. We don't, take the square root and then round to the nearest tenth. Instead, we're going to leave it under the radical symbol. So knowing that, I'm going to go ahead and I have my 2x minus 7. And that's going to be equal to either positive or negative the square root of 20. Now before I go further, one thing I want to show you is that Although 20 is not a perfect square, it does have a perfect square factor, right? 4 times 5 is two factors of 20. So when I multiply them together, they equal 20. So I could potentially rewrite this as plus or minus the square root of 4 times 5. Now I can take the square root of 4, but I can't take the square root of 5. So I'm going to do that. And when I do, I end up with 2 times the square root of 5. So 2 times the square root of 5 is the exact same value as the square root of 20. It's just in simplest form. So I simplified it down. Next, to solve, I'm first going to add 7 to both sides. Now, it doesn't matter where you write the 7. You can either write in front of the plus or minus sign, or you can write it at the end. I'm going to rewrite it in front, though. So I have 7 plus or minus 2 times the square root of 5. And then finally, I'm going to divide everything by 2. So that means we have 7 plus or minus 2 times the square root of 5 all over 2. You could even take that a step further, and you could separate it into 7 over 2 plus or minus 2 times the square root of 5 over 2. The 2's then simplify, and you end up with 7 over 2 plus or minus the square root of 5. So that's something if you want to take it a little step further. If you did leave it as the square root of 20, that's okay as well. We're going to continue working on that skill of simplifying it down further, but that'll be later on. So some things that you may have noticed when you were solving each of these is that it was not easy to do these, right? Sometimes you ended up with decimals, sometimes you ended up with fractions, sometimes you ended up with an irrational answer. So factoring and completing the square was not necessarily the best way to go. It was a little cumbersome. And in fact, the last equation, the only way you could solve it was by completing the square. You wouldn't have been able to actually do any factoring because it was irrational. Next, we're going to learn about a formula that gives us the solution to any quadratic equation, so it always works. All right, let's take a look at that. So here we have the infamous quadratic formula. So the quadratic formula is one of those things that I know I remember greatly from when I took algebra. But it's nice because basically this formula can be used to find the solutions to any quadratic equation as long as it's in standard form, so ax squared plus bx plus c, and as long as a, b, and c are numbers that where and a is not 0. Obviously, if a is 0, then it's no longer a quadratic equation anyways, but you do need a, b, and c to be numbers. So on the next page, we're going to look at an example that shows us how to use the equation x squared minus 8x plus 15 equals 0, and how to use it in the quadratic formula. One thing I do want to point out in this case is that when we're looking at the standard form, we have to be able to identify what a, b, and c are. That's a really important part of the process. So in this case, a is 1, b is -8, and c is 15. So let's go ahead and take a look at the next page. All right, so as I mentioned before, we identified a as being 1, b as being -8, and c as being 15. So if we look at the original equation states x is equal to -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So basically what you're going to do is you're going to plug in a, b, and c wherever you see a, b, and c. So we said b was -8, so we're going to take the opposite of -8, plus or minus -8 squared, minus 4 times 1 times 15, all over 2 times 1. The opposite of -8 is 8. -8 squared is 64. 4 times 1 times 15 is 60. And then 2 times 1 is 2. Then I'm going to take 64 minus 60, and I have 4. Next, I'm going to take the square root of 4, and we know that's going to be positive or negative 2. Then I'm going to separate it into two equations. One where I'm adding 2, so that's here. The other where I'm subtracting 2. So 8 plus 2 is 10. 10 divided by 2 is 5. And then 8 minus 2 is 6. 6 divided by 2 is 3. So this tells us that our two solutions are 5 and 3. And if you think about the original equation, which was x squared minus 8x plus 15 equals 0, if we were to solve this by factoring, it would be x minus 5 times x minus 3 equals 0, which would then give us a solution of 5 and 3. So it's another way of solving an equation using a big formula. So now what I would like for you to do is there's a total of 6 problems. I would like you to try to solve at least 2 of them. If you feel like practicing some more, go ahead and solve as many as you want, but you need to be at least 2. So go ahead, pause the video, use the quadratic formula to solve. All right, let's take a look at the first one. So here, my A is 1, B is 4, and C is negative 5. So I'm going to plug in. I have negative 4 plus or minus 4 squared minus 4 times 1 times negative 5 all over 2a, oh, not 2a, sorry, 2 times 1. Okay. Negative 4 plus or minus 16 plus 20 all over 2. I have negative 4 plus or minus 30, the square root of 36 all over 2. Then this is where I separate negative 4 plus 6 over 2 and negative 4 minus 6 over 2. Negative 4 plus 6 is 2. 2 over 2 is 1. Negative 4 minus 6 is negative 10. Negative 10 over 2 is negative 5. So we can see that the solutions are 1 and negative 5. All right, let's take a look at the second one. This one, A is 1, B is 7, C is 12. So I have negative 7 plus or minus square root of 7 squared minus 4 times 1 times 12 all over 2 times 1. That's going to be equal to negative 7 plus or minus 49 minus 48 all over 2, which is equal to negative 7 plus or minus the square root of 1 over 2. Okay, now I'm going to separate negative 7 plus 1 over 2 and negative 7 minus 1 over 2. Negative 7 plus 1 is negative 6. Negative 6 over 2 is negative 3. Negative 7 minus 1 is negative 8. Negative 8 over 2 is negative 4. So my two solutions are negative 3 and negative 4. All right, let's take a look at number 3. So again, we identify our A, B, and C. So A is 1, B is 10, C is 18. Okay, and just plug into the quadratic formula. So x equals negative 10 plus or minus the square root of 10 squared minus 4 times 1 times 18. Okay, all over 2 times 1. That equals negative 10 plus or minus 100 minus 72 all over 2. 100 minus 72 is 28, so I have negative 10 plus or minus square root of 28 over 2. From here, I need to simplify 28 because that does have a perfect square factor. So when I do that, I get negative 10 plus or minus 4 times 7 all over 2. And that simplifies as negative 10 plus or minus 2 root 7, root 7 over 2. Now I need to simplify. Now, if I were to separate out this into two fractions, it would look like this. Negative 10 over 2 plus or minus 2 root 7 over 2. And that allows me to see the simplification a little bit easier. Negative 10 over 2 is negative 5. And then these cancel out, so I'm just left with the square root of 7. So here I can see it matches the negative 5 plus or minus root 7. Let's take a look at number 4. Okay, A is 1, B is negative 8, C is 11. So x equals, the opposite of negative 8 is positive 8, so 8 plus or minus negative 8 squared minus 4 times 1 times 11, all over 2 times 1. 8 plus or minus 64 minus 44, all over 2. 8 plus or minus 20, all over 2. Again, 20 has a perfect square factor, so I simplify that to 8 plus or minus 4 times 5, all over 2. 8 plus or minus 2 root 5 over 2. And again, I separated out 8 over 2 plus or minus 2 root 5 over 2, which just simplifies to, oops, not 8, sorry, 4 plus or minus root 5. Okay, number 5. So A is 9, B is negative 6, C is equal to 1. So we have x is equal to 6 plus or minus negative 6 squared minus 4 times 9 times 1, all over 2 times 9. 6 plus or minus 36 minus 36, all over 18. So I know that's going to be 6 plus or minus the square root of 0 over 18. And this tells me that there's just going to be one solution since it's the square root of 0 is just 0. I'm essentially left with 6 over 18, which simplifies to 1/3. Okay, last one. A is 6, B is 9, C is negative 15. Don't forget that negative sign. X equals 9 plus or minus 9 squared minus 4 times 6 times negative 15, all over 2 times 6. So I did catch a little mistake. This should be negative 9 because it's the opposite of B. So now we have negative 9 plus or minus 81 plus 360, all over 12. 81 plus 360 is 441, so we have negative 9 plus the square root of 441 over 12. And 441, the square root of that is 21, so I have negative, oops, forgot my minus sign, plus or minus 21 over 12. From here, I'm just going to separate it out into two fractions, so negative 9 plus 21 over 12, and then negative 9 minus 21 over 12. Negative 9 plus 21 is negative 12, so I have positive 12. 12 over 12 just equals 1. Negative 9 minus 21 is negative 30 over 12, which simplifies to negative 5 over 2. So that's it for this lesson. Thanks for watching.